Thank you very much, and we'll get started here. And you can type your questions into the question chat box there, and we'll answer those after the call. So thank you again for joining, and here we go. So once again, the name of our company is Anark. We've been around for about 15 years, and throughout that time we've been working with large aerospace and defense companies to help them repurpose their CAD models for downstream use cases or applications. And so, for example, we built a 3D configuration tool for Boeing that enabled airline customers to interact in a 3D environment and configure seats and fabrics and things like that, would spit out a bill of materials. So we've been working with these large companies to help them reuse their CAD models, and so that's sort of our pedigree in this industry, and that's also why we're here to talk to you today. Is how do we reuse your CAD models and your model-based definition to create MIL-Standard 31000 compliant technical data packages. So just real briefly, here's a short list of our customers. Primarily for the past 4 years, we've been working with the DOD and the U.S. Army and U.S. Air Force to develop this technology that we're going to show you, once again, to publish 3D PDF-based technical data packages directly from SolidWorks. And truth be told, we started work with the Army, like I said, several years ago to develop this capability out of GoEngineer, or Creo as it's known. We also have this capability for Siemens NX, and we're working on CATIA right now. So we've got all the primary CAD packages covered. So I'm going to introduce Chris Garcia, and he's going to take us through some of these slides here.
Yeah, thanks a lot, Paul. Just as a bit of introduction, my name is Chris Garcia, and I'm responsible for business development here at Anark. On this blustery December morning, we're having our first real snow, which is great. Kind of looking forward to Christmas starting. Paul Peralt is responsible for product marketing and our CAD Edge relationship. So as Paul mentioned, we're going to be demonstrating this new product capability called MBEWorks, and in a nutshell, it is all about creating 3D model-based enterprise documents, and in particular 3D PDF documents. We have been working with Adobe and the DOD for about 4 years, and it's kind of culminating in a major announcement to be made by the Department of Defense in January. In fact, we're told probably towards the end of January they will announce the new DLA, Document of Purchasing Requirements for suppliers and prime contractors, called MIL-Standard 31000 Rev A, a name only a mother could love, I guess. We have been tracking the standard. We have been working with the DLA to put our inputs in, as many of you probably have as well. And originally it was hoping to be released in September, and then more changes were required, which we hoped then would be released in November. Then we hoped it would be released in December. And now the last announcement, which was made at the DOD conference in Gaithersburg, Maryland last week, which Paul and I were at, has it coming out in actually all comments and changes and requirements are going to be done January 15th, and the document will be released on January 31st or before. It's a major document. It's a major paradigm shift for the Department of Defense. It is going to help them eliminate the need for 2D drawings, which is a huge benefit for the DOD and for the suppliers that they'll be working with, of which many are you guys who are using SolidWorks as your engineering design tool. So In replace for 2D, what they call technical data packages, they will be requiring prime contractors and suppliers to interact with them through 3D technical data packages, which you're going to see a whole bunch of here when Paul gives the demonstration. Things you can do in a 3D environment, well, let me just describe a few terms. When we talk about model-based definition, at least in this little conference call, that will be everything you do in SolidWorks to design your parts, design your assemblies, to put in your engineering custom properties, and maybe most importantly, you will be doing 3D dimensioning and tolerancing, GD and T tolerancing, plus minus tolerancing in a 3D environment in SolidWorks, which Paul will show you, as opposed to creating 2D drawings. So, if you will, the complete product definition is built in a 3D environment. And then once it's in that environment, there's a whole bunch of things that non-engineers can do with that data if it's presented in a what we call a fit-for-purpose way. There are 4 major fit-for-purpose ways, which Paul's showing you on the screen here. One is to create a technical data package, which when we use that term, we pretty much mean any product definition that conforms to the DOD's MIL standard 31000 Rev A coming out here again end of January. But you can also make 3D PDF animated work instructions, which are not engineering documents at all, but they're manufacturing documents that were derived from the engineering documents. Or RFQs for purchasing guys to make 3D RFQs, which are much more interpretable than the equivalent 2D RFQ. And probably our favorite is 3D PDF inspection documents, which allow the engineering data to be repurposed into a 3D PDF inspection document where the critical features are highlighted and measurements on the shop floor can be directed, procedures for how to measure parts can be directed, and the critical dimensions and tolerances can be recorded and put back into the PDF. So all in all, when you take into account the elimination of 2D drawings, 2D technical data packages, and replace them with a 3D model-based enterprise, anyway, any derivative use of the engineering data downstream we call the model-based enterprise, the DOD is predicting significant savings, at least 27% of their engineering costs, mostly due to having to maintain, develop, archive, update, support 2D drawing packages. That goes away. And now the design intent is completely recreated in the 3D PDF.
And you know, another benefit is that there's no confusion. The model is the master. There's no argument about whether the drawing is the authority or the model is.
Yep, and you're going to show that, Paul, how that becomes very beneficial. If the primary objective is to streamline the way DOD works with the contractors by eliminating 2D drawing technical data packages, a very important side benefit is to eliminate the dependency the government has right now on proprietary CAD formats. Right now the Army has Pro-E models and they have to deal with Pro-E suppliers. The Air Force has NX models and they have to deal with suppliers who know NX. And the Navy has CATIA models, and they have to deal with suppliers that know CATIA. And that kind of splits the supply channel into only 1/3 as powerful as it could be. When they move to this open 3D PDF technical data package for the transmittal of engineering product data, all of a sudden now any supplier, and in particular SolidWorks suppliers, can begin to bid and engineer and create MC programs and inspection applications for any of the Department of Defense, be it the Army, the Navy, or the Air Force. They don't have to have Pro-E. They don't have to have NX or CATIA. They can have their CAD package of choice, which you guys have chosen to be SolidWorks, and a good choice indeed. So when you get to where you're no longer requiring a native CAD package to deal with the Department of Defense, and you're in a 3D open PDF environment, the amount of scrap and rework reduces significantly. Government predicts by 19%. And that's because now a supplier can open up the 3D PDF technical data package and look at the design intent and decide what it's going to cost, how they're going to make the part, all inside the free Adobe Reader. So no need to buy a dedicated CAD package just because you're dealing with the Air Force. You don't need to buy NX. You can use SolidWorks, and you can interact through this open 3D PDF format.
And there's another benefit here as well, for how scrap and rework is reduced. So there's one benefit: you're just interacting with 3D data, which a lot of folks you're going to see here in a second. You can understand the design intent better just because it's 3D, not a 2D drawing. But in addition to that, this is where ASME Y 1441 comes in. We can capture all that data out of all of these different CAD packages and embed it within the PDF. And that eliminates any ambiguity there might be about what the design intent might be. Yep. So we'll show that as well.
Yep, I apologize. A lot of jargon, a lot of terminology. Hopefully some of it you've heard before, but this is really a new era for communicating engineering data to downstream applications, be they manufacturing, be they purchasing, be they inspection, or any kind of manufacturing process, all without the need for 2D drawings. This may be the most important part of this whole seminar. Is we're going to be able to change the paradigm of how engineering deals with downstream users in a world that no longer requires 2D drawings, and then the savings are significant that come from that paradigm shift. So Paul, let me just go. Great, thanks. So all of this, again, culminates in a new military standard, which sometimes aren't very interesting, but in this case, MIL Standard 31000 Rev A is very interesting because in that standard, it describes all of those things that are required of a supplier to move into a 3D technical data package. And again, 3D technical data packages are the replacement for all the old 2D technical data packages that the government used to require from their suppliers and from their prime contractors. And that's very exciting indeed. So the release of that standard is predicted for middle to late January. At that point in time, then it will become the contract document of record for all new weapon systems that are being bid on through the Army, Air Force, or the Navy.
And this is happening at the meeting last week in Gaithersburg, the MBE Summit. I mean, there was several presentations there, major contractors showing examples of their 31,000 implementations.
Yeah, awesome. So you might think, wow, this has just come upon us over the course of a fortnight. But in fact, the MIL Standard 31000 has been under development for 5 years, and Anark's been part of that for 4 years. It has gone through many, many reviews, many program managers, the guys who are responsible for various weapon systems have had a chance to look at it and make their comments. And they've actually gone and done several production prototypes of the new MIL Standard 31000, 3D PDF TDPs, and have published a report showing how much of a benefit this is going to be to the Department of Defense and in like kind, probably to all manufacturers, whether they do DOD business or not. We all kind of know the holy grail of streamlining our processes to eliminate 2D drawings. And so the government is just pushing that as fast as they can so that they can reap the benefits. There's a study that we're going to point you to that just came out about 2 weeks ago, which is sort of the culmination of what it means for the Department of Defense to communicate with you as suppliers through 3D PDF, the technical data package, as opposed to 2D old technical data packages. And some of the highlights you're going to read in that study, just really quickly, 89% of the folks that worked on reviewing and interacting in these pilot programs claim that the 3D TDP had everything they needed. Everything they needed from a product definition perspective to make those parts or bid on those parts or inspect those parts or build spares and repairs off those parts, as opposed to having some missing information. So the standard turns out to be very complete. 91% of them said that this was probably the most useful combination of CAD data and viewable design intent data in a 3D PDF container. Very, very popular. And then in red here, 89% of the respondents felt that this was much better. Almost 90% felt this was much better than the old 2D drawing technical data packages that they used to receive from the government. And about 84% of them plan to use these 3D TDPs to help them define their derivative manufacturing processes off of the engineering data that's sent directly to them by the Department of Defense.
And what was that other stat about? So they sent out 2D drawings and they set out the 3D TDP, and when suppliers received the 3D TDP, more of them ended up wanting to bid because it was easier to understand and they could get, from art to part faster.
Yeah, that's great. Imagine if you were sent a 150-page 2D drawing package and you had to bid fixed contract to the government for the design or the manufacturing of some critical weapon system component. Well, you're going to make sure you understand the design intent clearly, and if you don't, because you can't figure it out, you're going to make a no bid. With these 3D PDFs, where the design intent is clearly articulated and easy to understand, it gives you much more confidence to bid on the government jobs. And the bidding process, and you're going to see here, the bidding process was much more efficient and much more bids that the government was able to receive when they were dealing in 3D PDF TDPs. A couple more points, and maybe this one in red here, substantial time and cost savings resulted. These are the suppliers now saying, yeah, this is much easier. I can deal directly with the 3D data, understand the design intent clearly, and then, as you're going to see, derive my SolidWorks parts and assemblies directly from these 3D PDF TDPs. But this is my favorite statistic. The overall time for the government to get parts back from their suppliers was reduced by 50%. The one example that's defined in the study was that they were able to go from an 81-day cycle to a 41-day cycle. And why that's important, even more than the cost savings, the time savings means that parts can get back out to the warfighter faster. And that's really what drives this entire initiative. Yeah, it's going to save big bucks, but it's also going to get parts back to the warfighter who's been in combat, who needs a new spare part for his machine gun or for his Bradley fighting vehicle. And so when the parts can be refurbished or repaired or even design upgraded faster, and in this case 50% faster, it's going to save lives. And that's really kind of what gets us up in the morning, is we're doing something good. And we're really pleased to see that a lot of people, particularly SolidWorks users, are getting very interested in this 3D PDF technical data package environment. This whole report, this assessment, very well done, with all the statistics, can be found at modelbasedenterprise.org, and you'll be able to see it towards the lower left-hand corner. We suggest everybody go there and review that report, or contact CAD Edge guys, and they can get you to that report. So, Paul, with that, let's stop talking, and you show them the good stuff.
All right. So we'll still talk, but we'll show some good stuff instead of PowerPoint. So what I'm going to do here is just pause real quick. This image that we're looking at right here, this is, sort of when we talk to people, what many people think of 3D model-based definition. And sort of what we're here to say is that it's not like this. This is not a good example. Basically, when you start annotating in 3D, and when you start adding model-based definition to your model in SolidWorks, there are really, really easy ways to organize this data just like you would in a 2D drawing. And so what we're going to do is show you how to essentially annotate your model, go from this to this representation in the PDF document, and we'll explain what this document contains, what data, what information it has. But as you can see, this is a well-organized presentation of only selected dimensions and tolerances within this particular view. And so we're going to show you how to do all that. Now, one thing I wanted to point out, you'll see here this annotation, this surface profile is highlighted in red, along with all of the faces in this model that are related to that annotation. So that's the ASMEY 1441 visual response. That's not created by Anark. That's not created by the PDF. That's created by you, the design engineer, in SolidWorks when you use GIM Expert and reference dimensions. So it's a natural consequence of annotating your model. So let's get out of the PowerPoint right here. I'm going to pop over to SolidWorks, or actually no, let's open up some PDFs first. Sorry about that. So first of all, we're going to open up a PDF. This is a document very similar to the screenshot we just saw in the presentation. I'll make this full screen here. Now, what we're looking at is a multi-page PDF document. This is just the first page, which is the title block. Some people use the title block in drawings. We can extract that from the 3D environment in SolidWorks and create a standard PDF page out of that. Now, other folks, other customers that we're working with, don't do the title block anymore. They represent this information right here within the 3D page of the PDF document. And so just to provide a little tour, you can see up here, let me just turn off my toolbar here real quick. You can see that we've got things like the title and the part number and the revision, who the design engineer is, inches, maybe what standards were followed, notes, etc. In other words, all the data that you would normally see in a title block, we can represent here in the PDF as well. Now, here's the 3D view. Of course, you can rotate and spin and interact with the model in this way. Down here at the bottom, we have a row of thumbnails, which are really buttons that we can click on. And when I click on each one of these buttons, what we're doing is we're essentially activating a view, an annotation view, that was created in SolidWorks and extracted and then published into this document. So each one of these annotation views, just like this one, contain a number of different 3D dimensions and tolerances, other annotations, and the real value here of not only interacting with the model in 3D, but is that the visual response characteristic that shows me with zero ambiguity, what 4 CAD features this particular annotation relates to. And so we can go through our model and interrogate all these different holes here to find out exactly, without a shadow of a doubt, that I need to drill this hole out at 0.156 and 0.6 depth. Go ahead, Chris.
So, Paul, you're showing really the power of the PDF format. Again, you're going to show how we generate this from SolidWorks. But what's cool about this is for the non-engineer, the non-SolidWorks geek, this is very easy for somebody to navigate. PDF is the world's most popular format, and the free Adobe Reader is the most ubiquitous, everywhere present 3D viewer in the world. In fact, it's on over 98% of all computers in the world and 100% of all DOD computers. So as a purchasing guy or as a manufacturing guy or as somebody who's trying to create some manufacturing process information, I can go to this PDF and I instantly know how to navigate through the engineering data that has come originally from in this case, a SolidWorks session. So that's really a powerful part of the PDF is it's well known by everybody and almost everybody in the world and all DOD folks in particular.
Yeah, it's everybody we speak with, it's just that next level of communication in the design and manufacturing environment. So so that's a technical data package, but of course part of MIL Standard 31000 and certainly for parts legacy parts that have been designed previous to that standard being released, we can include 2D drawings if necessary. And what some folks are doing is that they will do their critical dimensioning and tolerancing here in the 3D, and they might have a drawing that provides some basic dimensions and other information like that, and we can attach those to these TDPs as well.
Yeah, and a lot of times, Paul, we'll see that the 3D will be defined for the mechanical parts, and then they'll create 2D drawing layouts of wire harnesses or electronic diagrams or floor plans if you're creating some kind of a machine design. You may very well attach to this 3D PDF a set of 2D floor plan drawing layouts, and then the entire, if you will, presentation of how the part or the assembly is supposed to be manufactured within the environment of the shop floor can be all encompassed in one multi-page 3D PDF.
And you know, that just sort of demonstrates the flexibility and the power of this format. What Chris was mentioning about attaching files. Well, here's a standard feature in every version of Acrobat and Reader out there. I can click on this paperclip icon, and we can see that we've got some attachments here embedded within the PDF document. So in this case, we've embedded a step file along with this 3D data within the PDF document window here itself. This can be exported or saved to your desktop. So it's a great way to pass a manufacturable solid within this package to your downstream customers, if necessary. So this is purely optional here.
And Paul, what's neat about the paperclip here is any attached documents inherit all of the properties of the PDF. As an example, they get shrunk down, they inherit the security, there may be a password protection that you want to use on the PDF so that nobody that's not supposed to gets access to this data, but a whole raft of security provisions that the PDF has natively are inherited by these documents that are attached. And they aren't PDFs necessarily at all. This is a step file. You could attach an Excel spreadsheet. You could attach a SolidWorks model if you wanted. But they all inherit the architecture of or the protection of the 3D PDF.
Yeah, and for those out there, there's no shrinkage. There's maybe compression. Sorry. So another aspect of the PDF here is the model tree. And the model tree provides access to all of the custom properties or configuration-specific properties that may have been created in the SolidWorks session. I'm going to get into this in SolidWorks in just a second. So it's a great way to interrogate the model. And of course, if we click on any of these annotations here, we can see the semantic or machine-readable definition for that particular annotation. So, if I'm having trouble reading this or viewing this with my eyes, my eyesight's bad, I can pop over here and I can see, oh, okay, for sure, this is actually a diameter with a hole depth. I might even want to export this data to a CSV or an XML document. So all of this information is contained here within the PDF, and it can be saved or it can be interrogated, etc. It's a complete product definition.
And Paul, not to get too deep into the weeds here, but the column on the left is called semantic dimensions and tolerances, and when they say semantic, they mean it's machine readable. And why is that important? Well, right out of this PDF, a generative NC programming software or a generative inspection programming software could extract all of the necessary information, design intent / geometric tolerances / feature type, to allow it to automatically create the NC program or the inspection program or process planning in a generative fashion. And this is also part of the DOD's vision for moving into more automated processes down the road. You see the tolerances in the 3D view, but the machine tool or the inspection CMM will read those tolerances out of the semantics on the left-hand column.
Yeah, this is the PDF is just it's a perfect container for this type of information. So let's look at another sample really quickly. I just want to show one more thing before we show you how to build these. So let's look at a first article inspection document. And if we have time, I'll open up some manufacturing work instructions after we go through the SolidWorks. So this is a document. Once again, it's a PDF document, and its use case or its purpose is slightly different. So whereas the TDP wants to define the complete product definition, this document wants to be a standard procedure for inspection of parts coming off the assembly line or so. And in this case, we're not showing or we're not using the complete product definition. We're actually filtering out everything that's not relevant for performing an inspection or digging into the critical key characteristics, etc. So in this case, what we can do is we can see the particular dimension that we want to inspect. I can see or read the machine readable values that are associated with this particular dimension. And so I can, take out my calipers here on my virtual inspection station, and we can do a measurement of this part. And you can see that we can calculate the deviation right here within the document. And after I enter my virtual measurement here, I can save it to the document, move on to the next. Let's do another virtual measurement. We'll make this one right on the money. And I can save that. So every time I click this commit button, I'm actually saving this value within the PDF document itself. We'll do one more. Let's do 1.31. That'll be in spec. Now, after I've done all this, after I've gone through and inspected this, all the different key characteristics, I can sign my digital signature into this document, which will lock it from tampering or modification by anybody else. I save this to my desktop, and now this becomes a business record or a document that I can keep on file in case I ever get audited in the future or so. I mean, I can prove that Paul Peralt inspected this particular part on this date and time, etc.
And again, Paul, these critical dimensions, subset of all of the dimensions, were generated in SolidWorks, put into this special inspection template, which is easy to create, and the ability to go into open setup, measure the part, and have this document tell you if the part is in tolerance or not is very, very powerful. And you can even put best practice inspection techniques in this document, so the guy knows how to set up off of datums, knows how to go in there, and if you're doing some kind of a paper gauging analysis for true position tolerance. Everything he needs to know on how you want him to inspect this part can be locked into this 3D PDF inspection document. And then, as you said, when you sign it, this is very critical for traceability, you as a supplier said, I've measured this part, I'm going to send it back to the government as a part that we commit to being in tolerance based on the inspection requirements that the government has defined or anybody's defined. It locks it in to a particular person, in this case Paul Peralt. It says on December 17th or December 18th, Paul Peralt inspected this part and decided that if it's in tolerance, that he commits by his oath that that part meets tolerance. And now that becomes a document of record for all parts that might go out into the field and provides perfect traceability for how this part got into the field.
And once again, it all starts with committing to creating model-based definition within SolidWorks and eliminating the drawing. So let's pop over into SolidWorks here really quickly. I'm going to show you just the that AR-15 part here. This is a standard SolidWorks part. Just want to say that no Anark software was used to model or annotate this. That's not what we do here within the SolidWorks environment. I'll show you what we do in just a second.
To say another, this is standard dimensioning practice inside of SolidWorks through a function called DimExpert or reference dimensions, and it's been in SolidWorks for a couple of releases now. Anark just leverages this environment to make the 3D PDFs.
Yes, exactly. So basically the procedure for building this, and I'm going to do this interactively in just a sec, is that we would just go ahead and model our part, and then what we would do is create any number of different 3D annotation views. And so these annotation views are essentially the analog to the projections that we might include in a 2D drawing. And so if I want to create an annotation view, it's very, very easy. I can just right-click on my annotations folder here, and I can insert a brand new annotation view. And once again, I'll take you through this in just a second. Within each annotation view, we can then create, or use rather, DIM Expert to create all these different dimensions and GTOLs and datums, and all of the pink items that you see here were created with DIM Expert. So as I mentioned before, that ASMEY 1441 visual response is created by DIM Expert whenever we annotate a feature. And so here's that whole pattern that we saw within the PDF. And you see here when I click on this, SolidWorks is highlighting the CAD features that are related to this particular dimension, tolerance, and composite frame here. So all of these pink DIM Expert annotations here have that same behavior, and we can just pop through here and interrogate the model. And so, this right here, this is sort of, demonstrating the value of 1441. If I had SolidWorks, and if you sent me the model, this would be all I'd need, right? But most people, or many people, don't have SolidWorks, and many people don't have NX or CATIA, and so that's where the PDF comes in. And so our job is to extract all of this data and publish it into a PDF document that can be opened anywhere by anybody with Adobe Reader.
So Paul, I guess in the world of terminology, because I know we're throwing a lot, we would call this 3D model-based definition inside of SolidWorks. So it's being able to create the complete product definition, which does include these tolerance symbols and all the custom properties and all these annotation views for how to interact. This is one half of the MIL standard. It describes how to fully create a 3D product definition in lieu of, or in a replacement for, any 2D drawing package or 2D sets of SolidWorks drawings that you might have created in the past.
Yeah, and there's even a little checkbox in the standard that says, I want ASMEY 1441. That can be a requirement for the delivery. Now, some of the other information that we can add here to the complete product definition, we might be used to creating these title blocks in our 2D drawing. We can do that here just by inserting a title block table within our 3D view. We can embed a BOM table, a design table. Any of those types of tables can be embedded here within the 3D model space. And then, of course, we can publish that out of the SolidWorks session into the PDF. In addition, let me pop open here the file properties. So these types of, the custom and configuration specific properties, these properties often define, what material was used, maybe what standard was used, designer, etc. All of this data is pulled out of the SolidWorks session and published into the PDF as well. Now, if we were looking at an assembly, we'd also have, the ability to pull out, exploded configurations, cross-section views, anything like that. So what I figured, let's do this now. I'm going to close out of this document, and I'm going to open a part that I just created a couple days ago. It's a very simple part, but the procedures that I show you here will work for anything that you do. And so, basically we've modeled the part. It only has a couple features here. What I'm going to do is pop open my annotations view, or my annotations folder, and you're going to see that we don't have any views created. So one of the great things about SolidWorks is actually it's this feature within DIM Expert called the auto dimensioning scheme. And so what I'm going to do now is I'm just going to rotate my part a little bit. Let's pop into the auto dim scheme feature panel. And now what I'm going to do is just create a couple of different configurations here, and then we're going to let it do its thing. So first thing is I'm working with a prismatic part. I want geometric tolerances. Let's select a couple datums. So for my first datum, I'm going to select this bottom face here. Maybe my secondary datum, let's make this side. How about over here, let's make my tertiary datum this back face. So I could leave all features selected, But what I want to do is I only want to annotate specific features within this model. So I'm going to enable this radio button here, and then I'm going to go around and I'm just going to pick specific features within my model that I want to create annotations for. And so let's select this, another hole pattern. How about my slot? Let's actually add my my chamfer here. And so I've popped around the model and I've just created or selected a couple of the features here. And now what I'm going to do is hit the Go button, and DIM Expert is going to automatically annotate and create different annotation views that these annotations fit in. And so what I'm going to do is I'm just going to hide a couple of these. Now we're going to activate and orient some of the views that DIM Expert created. And so we've got this nice and clean layout here. Only a couple of annotations in these particular views. I can change to another view just by right-clicking and then selecting Activate and Orient. And if I want to, I can just move these around and clean them up a little bit just to preserve some of the spacing. And let's put this guy over here actually, and maybe this guy over here. And so it's a really great way not only to annotate your model, but also to save a ton of time. So what we just did here is that we annotated this model. We didn't have to go and create a drawing. We didn't have to involve drafting, etc. All of this was done automatically here by DIM Expert.
And Paul, I just wanted to add, for those of you who are squeamish about geometric dimensioning and tolerancing, this DIM Expert tool does a great job automating the application of the GD&T standard called Y14.5. So you would look like a brilliant designer if you let DIM Expert go ahead and create your tolerance schemes based on the GD&T engines inside of SolidWorks DIM Expert product.
And the other thing that's great about DIM Expert is that you saw me toggle on this Show Tolerance Status. This is a great tool for getting an idea of perhaps what types of features within the model I need to add some tolerances for. So what it's doing is it's showing me a partial solution here for this entire model. And then I can go in and manually create additional widths or basic dimensions or heights or perpendicular dimensions, that describe the thickness or the height or the depth of this part.
So in this case, Paul, everything in green is fully dimensioned. No need to add anything additional. Is fully defined, and those things in gray are not yet defined and need some more tolerances applied to them.
Exactly.
Great.
And so what I'm going to do here is I'm going to right-click and create a annotation view manually. And the way that we do that is we right-click on the annotations folder. I'm going to insert an annotation view. I like an isometric view to be part of my technical data package. So I'm going to just select isometric here. Of course, if I created a custom orientation, that would show up in this list here as well. And so now I'll just click OK. You see here that there's my new annotation view. It doesn't have any annotations in it. So it's a nice, clean, well-organized model-based definition schema that I've got going here. Now the next thing that I'm going to do is I'm just going to right-click and rename this default. And so when we do that, we add a default view. It's a little trick we do. We're going to activate that view by default when we publish the PDF. Now, some things that other people might want to do, some people might want to add, maybe a proprietary or a distribution statement here. So you see that I've just used a basic note object. Now I can type in, do not distribute. Or I could link this to a property, a file property that I might have created previously. I could paste in here my legal, what am I trying to say? Distribution statement, etc. So very easy to add 3D annotations of all different types. And so just to sort of give you a little bit more detail here about what you can do. You don't have to use DIM Expert for everything. You can use any of the what we call the basic reference dimensioning or the basic dimensioning tools that SolidWorks provides. So if I wanted to create a ref dim just click on this button and then I'd measure between two faces, etc.
And just to be clear, Paul, they've seen nothing in Anark yet. I mean,
right.
We're into this now 45 minutes, and we're highlighting the model-based definition, again, product definition inside SolidWorks, all 3D, all GD&T, all annotation views. But now, if we could, let's show them.
Okay, yeah, so thank you for attending our SolidWorks demo here.
Yeah, right.
So what we're here to show you is Anark software. Anark software is actually two components when we talk about Anark Core MBEWorks. And so those two components are, one, we have a custom add-in for SolidWorks 2012 and 2013. You can see here that we've got a tab for our add-in called MBEWorks, and it provides 4 buttons here. The other component in this solution is a desktop application called Anark Core Workstation. So the add-in is actually creating a bridge between SolidWorks and our desktop application, which does all the hard work behind the scenes when we push these buttons up here. So what we'll do here is let's publish a MIL standard compliant 3D PDF technical data package. So the first thing that I want to do is I'm going to click on my preferences, and we're going to select what type of data that we want to publish into that PDF. So GD&T, that's geometric dimensions and tolerances. We're just going to stick with our top level. If I had an assembly, I might want to export everything, but that can create a lot of data. But so most people just use top level. I don't have any supplemental or reference geometry in this session, so I'm not going to export that. I'm going to output or publish all of my attributes. Those are the custom properties. In our PDF document, we're going to export visualization data only. So that's what's going to be represented within the 3D, within the 3D view. So I can change my slider here to make that high res or low res. We're also going to output a step file automatically. We don't have to create that beforehand. It's created and published during the publishing process. We're going to make our toolbar visible. I don't like that, so I'm going to turn it off. And then, of course, if we've got a title block or other types of objects, we're going to embed those as well. So I just set those and forget them, and then I pop over here to my Publish button. I'm not going to save this. And what we do is we pick a destination for our PDF. That's just going to show up on my desktop. And then the second thing that we do is we select a template. Now, what's a template? A template is actually the empty PDF document that we pour all of the data into. And so you can see here, this is where the 3D is going to go. These objects down here, this will have those thumbnails of each annotation view. This is the other data. Now, I'm just going to warn you here that I don't think that I've got a whole ton of file properties, so we're not going to fill out probably everything. But let's go back here and publish again. And okay, we've got our template selected. Let's choose our TDP template. The template really drives the application. This is, the functionality in the display for the TDP or the inspection document or the work instruction for that matter. So we're going to select this template. We're going to click OK. And now, Anark Core MBEWorks is going to talk to SolidWorks through the SolidWorks API. It's going to extract the solid geometry, create a step file, all of these different annotation views, all the dim expert dimensions, all the custom properties, and it's going to create this PDF document. It's going to open up here in just a second that gives us the complete product definition in a PDF document. It's essentially everything in SolidWorks except for the feature tree. And so there's all of our different views. There's our associativity. You can see here the hole pattern with the diameter and the tolerance. There's our what is that? Our flatness? No, flatness tolerance. Perpendicularity. Sorry about that. With datum A, B, and C. I always get those two mixed up.
Yeah. It's late in the Christmas holiday.
Late in the Christmas holiday. So there's all of our views. We can toggle between these. And like we showed before, there's our step file created automatically. And so that's it. It's really easy to create these documents. We've spent a lot of time integrating this within the SolidWorks UI and making this a piece of cake.
Yep. And Paul, just one more point. All those custom properties from SolidWorks are over here in the left-hand column. So imagine now, I mean, you did that in a really no time at all, honestly. You might have had to have added a few more tolerances to get all of those gray surfaces to be green, but soups to nuts. You just created a MIL standard 31000 compliant 3D PDF TDP from start to finish in 5-6 minutes. The beauty though now is me, a non-engineer, you just email that to me. It's a very lightweight email. You send me the 3D PDF product definition. You put a password on it so I don't monkey around and give it to somebody I shouldn't. But now I can now use this as my engineering product definition. I can send it to purchasing. I can send it to my manufacturing guys. I can have guys begin to interact with this document. There's commenting. There's markup. The whole Adobe platform is now at my disposal for interacting with this data and communicating back to you things that I might want to tell you about the design that you've sent me. Okay.
Yeah, it's a great package, and we fully expect there are going to be a lot of these documents flying around in the supply chain. And so there's some other additional capabilities that are pretty impressive as well. So I'm going to close this part here. And one thing that I wanted to just call out, well, actually, let me just open that up one more time. One thing I wanted to call out, within this Preferences panel, this checkbox right here, Visualization Data Only, this is a choice that you have as the publisher about whether you want to embed just a lightweight geometry, or if I disable this, the actual geometry within that PDF window will be a solid model. So for example, if I didn't have step selected and I didn't have this Viz Data Only selected, the document that I receive would actually contain an engineering BREP solid model within the PDF document. And so there are cases where you might want to do that. Go ahead, Chris.
Yeah, okay. I was just going to say, suitable for manufacturing.
Suitable for manufacturing. So let's pop over here into our samples folder, and I'm going to show you a TDP created from NX. And so this was a part that one of our customers gave us. This is from Honeywell. This is a very sophisticated model. Let me just activate a view here so you can see. This is I think it's a bushing or a seal for, well, it doesn't matter what it's for. In any case, there's a lot of features in this model. And so they created a 3D PDF TDP. Here are a number of different cross-section views. Now, once again, this was published from Unigraphics, from NX. And we've got that same 3D ASME-Y 1441 visual response here. I can click on these datums or any of these width dimensions, and we can see without a shadow of a doubt, again, what this dimension is here that the designer is trying to communicate. So there's a PDF document, and so I'm going to close this now. Now what we're going to do is go back into SolidWorks. And so we might want to, or we might receive this from Honeywell. We might be working with them, maybe creating some tooling. And so here I am, I'm a supplier, I'm working with SolidWorks, and what I want to do is now I'm going to come over here to my File Open dialog, and this is a new feature that we add into SolidWorks whenever MBEWorks is available or installed. Now you're going to see here at the bottom of my list, we have an entry for Adobe 3D PDF. So I'm going to navigate over to my samples folder. We're going to select our NX PDF that my Honeywell partner mailed me. Now we're going to click Open. And so what does opening a 3D PDF in SolidWorks even mean? Well, what we're doing is we're extracting all of the product geometry, all of the dimensions and tolerances, all of the custom properties, all of the views, all of the complete product definition out of that PDF document, and now we're going to recreate it here in SolidWorks. And the reason we're able to do this is because that PDF contains a solid model. And so SolidWorks right now is rebuilding that product geometry. In just a second here, it's going to finish up, and we're going to see, one more second here, it's just adding the views. So we're going to see here that we've imported that complete product definition into SolidWorks that I can now reuse. And so here, let's activate an annotation view imported from the PDF document. And so, hey, wow, there we go. It's the exact same thing that I saw in the PDF with the same associativity, with the same design intent available here now in SolidWorks, so that, if I'm going to, again, if we're going to manufacture some tooling for this particular part, I don't have to stumble through 100 pages of drawings and remodel this. I can create a model directly from this solid that we imported and save myself a bunch of time.
So, Paul, this is kind of amazing, and the first time people might have seen this, so I just want to take them through this carefully. This part that Paul's showing you started as a native NX model by a prime contractor for the Air Force. It had, in NX, he created his what are called view states for deciding how the GD&Ts were going to show up. He created his custom properties equivalent. He created all of his GD&T symbols and made them associative, or basically the design intent was described in these 3D annotations. The Air Force then said, hey, you know what, send that to me in a 3D PDF instead of a native NX model, because I can't do anything with native NX models. So Paul then showed you before that here was the 3D PDF equivalent that Anark happened to generate from NX, and it contained all of the complete NX product definition for this particular part. Now, in theory, an email was sent by the Air Force to a SolidWorks supplier saying, hey, I need you to create some tooling off this part. I have a 3D PDF, TDP. What are you going to, no drawings, please. Now all you have is to say, all right, I love 3D PDFs. I'm going to do a file open, 3D PDF, and now all of a sudden the exact part as seen by the NX designer is sitting inside your SolidWorks session. All of the GD&Ts are the same, all of the views are the same, all of the dimensions and tolerances without any error is perfectly now represented inside your SolidWorks session as a 3D SolidWorks model, from which then you can create tooling, you can create finite element analysis, you can do whatever you can do with a SolidWorks solid, you can now do with this part. I think it's just fantastic.
It's really cool.
Just brilliant.
So let's go back here to the PowerPoint. Sorry, we're running, got a couple more minutes. So why PDF? Well, we love PDF. It's already installed. You don't, well, sorry, let me just start from the top. First of all, it's free if you don't have it. Second of all, almost everybody has this, 98% of the world's computers. So there's no deployment cost. There's no deployment configuration. IT doesn't have to get involved. People can already open these documents. Plus, there's this huge platform infrastructure built around the PDF format. Adobe spent the past 10 years building that. Learn about it. It's great. It's really cool. There's a lot of things you can do with PDFs. So some of the other things that we just wanted to, just highlight with the capabilities, we can extract the complete product definition from SolidWorks. We can publish a wide range of different types of PDF-based, model-based enterprise documents. In other words, documents that are derived from the authoritative CAD model that are then reused or republished into these derivative documents for a variety of different use cases. We've got SolidWorks functionality, which we just saw. We also have same type of solution for PTC's Creo, Siemens NX, and we're working on CATIA V5 right now. So
let's just get to we have 1 minute left.
Yeah, there we go.
So if you don't mind, I'll just kind of wrap up. The MIL-STD-31000, it's all about 3D technical data packages. It's been under development by the DOD and Adobe for the last 5 years. It really is a paradigm shift that is useful for the entire DOD infrastructure, prime contractor, subcontractor, but really for the rest of the world. They're helping us as an industry move away from 2D drawings and into a complete 3D, free-to-view product definition, which is just really, really cool. And as that report said from the DOD, it's going to save money for sure, but more importantly, it's going to save lives, because the parts that the government needs, you as a subcontractor will be able to generate them at least 50% faster. And we think that's just really an important thing to keep in mind as we help the government push 2D drawings out of the way and move into this 3D complete product definition on the backbone of the 3D PDFs. On behalf of me, just want to wish you guys all Merry Christmas, God bless, and everybody have safe travels over the next couple of weeks.
Thank you once again for your time, and we'll answer your questions. You know, we're going to save all those things, and we'll get back to you about the questions that you've submitted. So thank you once again for your time.
Bye-bye.